Okay, so I thought I should include this. Everything we've seen so far looking at the code, here where I'm testing it, I know on my Lenovo laptop that when I plug up that particular microcontroller, it assigns it COM6, which is a virtual serial communication port assignment. But if I plugged up to a different computer, it might not be COM6. So we need a way to determine what port that's on. And since these videos are being put together as sort of a tutorial series going through all the steps in case kind of teaching how to do this, going through all the steps, some of the options for doing that aren't very good. Well, if we're on the device, we can go in Device Manager, plug that up, and rename that port manually. But again, we have to be on the device to do that. We need something that's going to come with the code and just when it runs, it'll check it. So putting that on the Arduino, in order to do that, we have to go in and change the bootloader on the microcontroller, which is not difficult. It's not bad, especially knockoff Arduinos. The Arduino code was written very, very nicely. It's clean, well documented. It's easy to find, but it's not really an introduction to microcontroller thing going in and changing the bootloader, and you kind of risk bad things happening if something gets messed up doing it that way. So it's not a viable option. So what I decided to go with is a little script here to just check all the COM ports and see which ones are available. So two functions here. The first one just goes through every possible virtual COM port. Way back in the day, there was physical serial communication ports, and at that time, microcontrollers were given an assignment, so it should be in 1 through 12, but machines almost never have the physical serial communication ports anymore, so they're all virtual ones. And even though it should still have that old physical assignment on a microcontroller, be somewhere through 1 through 12, it could be anywhere in 1 to 256. So just run a loop through that, and each time check COM plus the next number. And basically all I do is open it and close it. And if that works, then I'll print it to the screen and add it to this list. Add it to a list of the available ports. And after running that, so here's the meat and the bones of this script. Obviously, the first thing this does is get that list of ports. And then afterwards, it's going to walk through every port in that list, and just echo out that it's checking it. It's going to open that. And this part's important. I'll come back and talk about the timeouts in a moment. Since an Arduino or a knockoff Arduino has to boot up when we do it from Python, give it time to boot up, write the command, get the read line, and just see if it's the result we expect when we say send status to our basic controller. And obviously that needs to be in some exception handling. Have a couple lines from testing it that I just left in there because if this needs adjusted, I figure I'll need those echoes again. But otherwise, an exception is expected, so it just passes. It's just a pass on the exception. It's like I kind of expect that to happen, so just keep going. And if it gets all the way through the list and can't connect, then it'll return none. And then here's the main loop. So it's going to call that find port method. If it's not equal to none, say we're connected and just echo back what COM line we're on, which obviously that would be different if we import this module to just run that method. This is expected to be imported, so hence we need the if name equals main to see if we hit run here or imported it somewhere else and hit run there. Just some Python stuff there. But a very important thing here when checking the ports is the timeouts. So timeout is the read timeout, and obviously write timeout is the write timeout. So it's going to wait 1 second for a response on both of them, and it'll send this string and wait 1 second, spend 1 second trying to read it, and if it doesn't, then it's just going to go back around the loop. The write timeout, however, and the timeouts do throw an exception, so that if this line wasn't commented out, it would echo back here to say what went wrong. The write timeout is very important because if one of those COM ports is connected to a Bluetooth device, and that Bluetooth device happens to be turned off, it will register the port, but it will basically wait forever trying to write it. So make sure you have a write timeout if you're checking the ports. Otherwise, it'll just sit there and hang on the writing. But basically, it just walks through every available serial COM port and just checks to see if any of them send back the right reply to determine if the controller is there. So let's do a quick run on this. I'll just run it from PowerShell, that way we can see the echoes come back. Copy the address here, then set location to that address as a string. And now Python find com port.py. I'll run this, and it will take a second to go through all those ports and check because it's not immediate. Okay, so I found all of them. Checking COM4. Couldn't do anything there. Checking COM6. Oh, connected to COM6 at a baud rate of 115.200. So that's the easy way of finding the COM ports. And as I mentioned, it's not hard to change it in the bootloader. That's very nicely written, well-documented code. But this is probably a better way to do it anyway. Just check all the COM ports. And the most important thing is make sure you have a read and a write timeout on everything. Because if a Bluetooth device is connected, it will show the port, but it will just get hung up on trying to write the line and never get to the read timeout error. But that's just a quick check to see if we're connected to the correct serial port. So I think I'll switch that over in my mouse, use that in my mouse functions instead of saying, or in all the functions, instead of checking directly, just do this. And obviously when we get over to the game stuff, I'm planning on doing that in Unity, so it'll be this same logic, only written in C# instead of Python. But just assemble a list of the ports, walk through them one at a time, making sure there's a read and a write timeout, and just check and see if any of them send back the right response. And if they do, then go ahead and connect to it. Otherwise, echo back a message or something. So I thought I should show that. That's kind of an important step. Because when testing, we know what it's going to be on, but if we plug this controller up to a different computer, we wouldn't know which port it's on.